Welcome back to the deep dive. We are really digging into some fascinating material today. It cuts right through the technical talk, the blueprints and specs.
Yeah, get straight to the financial reality.
Exactly. The huge economic power, often kind of hidden, that engineering and geoscience generate.
hmm And this is really a deep dive into the why behind it all. Why are these fields not just, necessary, but actually transformative for society?
Right.
We're not just talking about facilitating the economy. We're looking at the actual mechanisms, the
Mm.
core ways that infrastructure, how we manage resources, innovation, how these things actually build, well, national wealth in the long run.
That's a great way to put it. And for anyone listening who wants to grasp the full scope of their professional responsibility while seeing that direct line from technical skill to national prosperity, that's absolutely key.
It really is.
So our mission here is to unpack how those that research, those critical professional calls, how they create real, tangible economic ripples, across every single sector.
Think of it as a shortcut to understanding the ultimate so what, the economic impact of all this technical work.
Definitely.
And hey, if you find these kinds of insights useful,
Mm.
maybe especially if you're uh, working towards mastering these core concepts for professional exams.
Like the NPPE, for instance.
Exactly. Make sure you hit subscribe on the deep dive right now. We cover crucial topics that are really designed to help with that MPPE preparation.
Yeah, do it now. Okay, let's jump right in. The sources start with the most obvious benefit, right? The direct economic benefits.
hmm The immediate impact.
When a big project gets the green light, the first thing everyone sees is job creation. It's like this powerful economic engine just firing up.
It really is. It's like an instant stimulus package for a region.
Yeah.
You've got these massive infrastructure projects or resource developments,
Right.
and they need hundreds, sometimes even thousands of professionals. We're talking engineers, geoscientists, surveyors, technicians, project managers,
Yeah.
all those roles
And that income, it hits the local economy almost immediately.
instantly.
We don't even need to look far for a really good example, do we? Thinking about, say, the Confederation Bridge.
Oh, absolutely. Linking New Brunswick and PEI,
Mm-hmm.
that project was, well, a textbook case of immediate regional stimulus.
How so?
Well, over the, was it 5 years it took to build? It generated thousands of jobs, skilled trades, professionals.
Yeah.
And that wasn't just temporary work. It gave a significant, measurable, long-term boost to Atlantic Canada's employment rate overall. And it helped develop the professional workforce there, too.
But the value, it doesn't just stop with the person getting that direct paycheck, right? This is where that employment multiplier effect comes in. It's not just one job creates one job.
Oh, far from it.
Yeah.
For every direct, highly skilled job on the core project, let's say, a structural engineer designing part of the bridge,
Okay.
you need several indirect jobs to support them. Think about the logistics firms hauling the concrete and steel.
Right, the supply chain.
Exactly. Or the crews maintaining the heavy equipment, the local restaurants feeding the workers near the site. All these supporting roles pop up because the main project exists.
Huh. So engineering projects are essentially regional job incubators.
Yeah.
That's interesting. But the really lasting value, it comes not just from who is working, but what they actually build, doesn't it? You mentioned infrastructure.
Yeah.
The economic backbone.
Precisely. We're talking about designing efficiency right into the fabric of the economy. When engineers create better transportation highways that flow, ports that load faster, modern rail systems,
Yeah.
they directly cut down logistics time and costs for every business that needs to ship goods. Every minute saved in transit is money saved, essentially, across the whole economy.
And geoscientists are critical here too, right? Providing that foundational knowledge.
Absolutely. They ensure we use resources sustainably, find stable ground, and crucially, avoid natural hazards that could just completely derail a project, or worse.
So if you have that reliable, cost-effective infrastructure,
Yeah.
capital follows. It makes sense.
It does. That stable environment. It lowers production costs for businesses. It acts like a huge magnet, really, pulling in both foreign and domestic investment that might otherwise have gone somewhere else.
And innovation plays a huge part here too. It's not just about making old systems better, but actually creating entirely new industries sometimes.
Oh, absolutely. A catalyst. Think about the specialized technologies developed for the oil sands in Alberta, that engineering and geoscience innovation. It basically transformed Canada into a major global energy exporter.
Huge impact.
Or look at Hydro-Quebec, their groundbreaking work in hydroelectric engineering.
Right.
Those advances didn't just give Quebec clean power. They lowered energy costs so much that it became a primary reason for huge manufacturing industries to set up shop there.
Wow.
That's economic transformation, literally by design.
Okay, that leads us nicely into the next layer, which is maybe a bit more complex. Indirect economic benefits and capital circulation. We talked about the job multiplier, but how's the economic multiplier different?
Right. So the economic multiplier is more about the velocity of money, how
Yeah.
fast and how far it travels. It goes beyond just counting jobs and looks at the capital itself.
Okay.
When money gets spent on a major project, say government funding or private investment, that capital starts circulating. So it
Yeah.
goes into wages, obviously, but also purchases of materials, equipment, services, and then taxes.
Uh-huh.
The sources we looked at suggest this circulation can generate value that's several times the initial investment over the project's life.
Okay, let's trace that. Can we follow the dollar in a real-world example? Maybe like a big public transit expansion?
Perfect example. So the initial public money pays the construction contractors, right?
Right.
Those contractors pay their engineers, their workers, their suppliers. Those people then take their wages and spend them locally. They buy groceries, maybe renovate their kitchen, shop at local stores, pay property taxes.
So it ripples outwards?
Exactly. That circulating income stimulates growth in totally different markets: housing, retail, services, even more construction. It creates economic value way beyond what was initially budgeted for the transit line itself.
That makes perfect sense. So beyond that circulation, there's another quiet engine of long-term growth. Enhancing productivity. We hear that phrase a lot. More output per unit of input. What does that actually look like practically through an engineering lens?
Well, fundamentally, it's the difference between just throwing more resources at a problem versus using intelligence to solve it better. Professionals design solutions, think automation, better materials, smart data systems that maximize efficiency,
Meaning?
meaning you can produce more stuff or provide more services without needing a proportional increase in labor or energy or raw materials. You get more bang for your buck.
Can you give us a concrete example where that professional ingenuity makes a real financial difference?
Sure. Think about modern mining. Engineers design automation systems, maybe robotic drills or haul trucks. These dramatically boost the amount of ore recovered per shift. But they also improve worker safety, which has its own economic value, and reduce the labor hours needed per ton of ore extracted. That's pure productivity gain.
Okay.
Or, on a different scale, structural and mechanical engineers designing super energy efficient buildings, better insulation, smart HVAC systems. These can slash long-term operating costs for a business by, say, 30 or 40% compared to an older building.
And that saved money.
That saved utility capital. It doesn't just disappear. It gets reinvested in the business, maybe R&D, maybe expansion, or it gets returned to shareholders, fueling other economic activity.
So it's clear that competent work doesn't just attract investment, it actually protects it too. Investors want stability, right? And reliable power grids, efficient transport, responsible environmental management. These are all outcomes of professional expertise. They're basically prerequisites before serious capital gets deployed.
That stability gives us a critical competitive edge. Okay, so now let's maybe break down where these economic benefits actually land across the key sectors.
Right. Where does the value accumulate? Let's start with the bedrock. Natural resources and energy. This feels like the heartland for geoscience work.
It absolutely is. Geoscientists are kind of the scouts, right? Identifying and evaluating critical resources, oil and gas, minerals, timber, and crucially, things like groundwater supplies.
Yeah.
Then engineers step in to design the systems for safe, efficient extraction, processing, and getting those resources to market, distribution.
And the economic scale here is just massive for Canada.
Immense. This activity is a huge contributor to our national GDP. It generates enormous export revenue, and maybe just as importantly, the royalties and taxes from resource development are what ultimately fund a lot of our public services: healthcare, education, infrastructure maintenance. The scale is just staggering.
Okay, moving from resources to, say, manufacturing technology. How does engineering design fuel competitiveness there?
Well, innovation is just indispensable in manufacturing now. Think about automation, robotics. These are driven by industrial engineers, software engineers, mechanical engineers. They allow Canadian manufacturers to compete on the global stage, not just on price, but on quality and sophistication.
And we have some classic Canadian examples of this, right? Turning expertise into major trade assets.
We certainly do.
Yeah.
Think about technologies like the CANDU reactor or the Canadarm on the space shuttle and space station.
Iconic examples.
Exactly. And they weren't just symbols of technical skill. They became highly valuable intellectual property. exportable commodities. They led to international trade deals, licensing fees, significant foreign revenue flowing back into Canada. It's proof positive that engineering excellence translates directly into global financial leverage.
And that ability to export expertise, it extends into areas like public works and sustainability too, right? These services, they underpin our quality of life, but they also cut business costs.
For sure. Think about something as basic as a functional water treatment plant or well-designed road networks. They prevent disease outbreaks, which is a huge economic cost avoidance. They reduce traffic congestion, saving fuel and time. They lower maintenance costs over the long haul if designed properly.
And connecting this to the bigger picture, environmental engineering seems increasingly critical for economic resilience. How's that?
Well, environmental engineers and geoscientists are designing cleaner technologies, figuring out how to manage industrial waste safely, ensuring resource extraction is done responsibly.
Meeting regulations, essentially.
Yes, but it's more than that. They are critically reducing the risk of massive long-term environmental remediation costs down the line. Avoiding a huge cleanup like a contaminated river or a major spill is often a multi-billion-dollar economic protection strategy. It safeguards the long-term health and viability of key economic regions.
That's a really important insight. And it transitions us perfectly into our final segment here, looking at long-term stability, risk management, and crucially, ethics. Let's focus first on how innovation becomes a durable, bankable asset.
Right, so we're talking about things like patents and intellectual property creation. That innovation that comes out of R&D, especially in fields like energy tech, advanced materials, digital systems, it directly drives national competitiveness.
Because those patents are assets.
Exactly. They're legal assets. They generate revenue through licensing agreements, or they give a company a unique market advantage. Governments understand this. That's why they support R&D through things like tax credits or specific funds for, say, green innovation. They know that IP is a key part of future export wealth.
But maybe even more vital than creating new wealth is protecting the wealth we already have. Risk management has to be seen as a financial tool, doesn't it?
It's the ultimate insurance policy, really. Professional judgment, applied correctly, prevents catastrophic economic losses. We have to remember the public investment in infrastructure, in major projects, is enormous. Protecting that investment is just non-negotiable.
Can you give us a powerful example where that professional diligence saves, potentially, billions?
Okay, think about rigorous geotechnical assessments. The work geoscientists and geotechnical engineers do before any major structure goes up a bridge, a skyscraper, a dam, a mine tailings facility.
Yeah.
That work identifies unstable slopes, weak foundations, potential seismic risks. Getting that right prevents landslides, foundation failures, catastrophic collapses. Imagine a major bridge collapsing in a city or a tailings dam failure near a town.
The consequences would be unthinkable.
Exactly. Not just the tragic loss of life, but the economic fallout is staggering. It can halt economic activity for years, trigger billions in lawsuits, insurance claims, shatter public trust, which itself has an economic cost. The fee paid for that initial geotechnical work is, frankly, a tiny fraction of the potential loss it helps avoid.
So the professional's true value is often defined by the disasters they prevent from happening, the negative numbers they keep off the national ledger.
Absolutely. And this ties directly into ethical practice. Because true professional value, the kind that lasts, has to be sustainable. It has to be long-term.
Meaning professionals need to balance cost and safety.
Precisely. Designing solutions that are cost-effective, yes, but also safe. And considering not just the upfront construction bid, but the full life cycle costs of a project.
What does full life cycle cost entail?
It means looking at the total cost of owning and operating that piece of infrastructure over its entire lifespan, maybe 50 years, maybe more. That includes maintenance, energy consumption, repairs, environmental impacts, and eventually decommissioning and disposal.
Ah, okay.
So sustainable practices like designing buildings for low energy use, specifying durable materials, planning for renewable energy integration, doing a thorough life cycle analysis. They might seem slightly more expensive initially, but they create enduring financial value. By drastically cutting those long-term operating, maintenance, and resource depletion costs over the project's decades-long life. It's about long-term economic health, not just short-term savings.
And finally, this competence, this expertise, it doesn't just stay within our borders, right? Canadian professionals contribute globally.
Oh, definitely. We export expertise. Think about Canadian firms involved in international mining exploration, or consulting on major infrastructure projects around the world, or contributing to complex humanitarian engineering challenges.
And that brings value back.
Absolutely. Exporting that high-level technical know-how enhances Canada's international reputation, builds relationships, and yes, brings essential foreign revenue back home.
Okay, that really pulls it all together. We've seen how the economic value created by professionals spans everything from direct jobs
Right, and the multiplier effect.
to making the whole system more efficient, generating innovation that becomes intellectual property.
And maybe most importantly, that indispensable role of managing risk and preventing massive economic losses.
Mm-hmm.
The takeaway really is that the scope of professional work is fundamentally economic. You have to remember that the ultimate foundation for our national economic resilience, it lies in how responsibly we develop, manage, and protect our infrastructure and our resources.
So here's a final thought for you, our listener, to mull over. How does balancing that immediate need for efficiency and cost management with the ethical imperative for long-term, sustainable, safe design? How does that balance define the ultimate enduring value that professionals like you create for society?
It's a crucial question. And if you're looking to really master these kinds of crucial concepts, especially you prepare for the NPPE exam, make sure you subscribe now. You don't want to miss any of these deep dives.
Well,